Today's talk will be on the four recent SIPs we just proposed. So we proposed these, I think, 2 months back at Sui Summit. And I'm just going to go in order on how we released them. If you don't know, you can always find them on the SIP GitHub page. If you look at pull requests, you can see all the open ones, but we'll be going over SIP 52 to 55. And one disclaimer before getting started, disclaimer about this talk, but also disclaimer about the SIPs themselves. The purpose of these SIPs were to kind of present a problem that the team has envisioned on Sui, and we've seen these problems for the years we've been building on Sui. So they're mainly about presenting the problem and then presenting a solution, not necessarily the solution, just a solution that gets the problem solved. But I think there's ways that we can evolve this. So I'm hoping through means like today, through this conversation, through GitHub and all that, we can come up with better solutions. So it's really just about presenting the problem and then presenting a way you can solve it. Okay, so again, there are 4 different SIPs we'll be going over. SIP 52 to 54. And starting with SIP 52, this recommends or proposes adding 2 different functions to the Sui framework, the destroy zero, and we'll get into this. SIP 53 is all about adding a new ability modifier to Sui move, the singleton ability. SIP 54 is about one-click trading. And then SIP 55 is about SIP 55 is all about allowing you to construct P2Bs that can both have parts of it that fail and also parts that succeed. Right, so starting with SIP 52, this was one we didn't really plan to create leading into Sui Summit, but I was working on a contract and was facing with a really annoying issue, and it just kind of led to this. And the issue really bothered me, so I want to walk you guys through that issue so you guys can also be bothered. So in the scenario, let's build an AMM. I wasn't building an AMM, but same idea applies. Right, so in our contract, we have this pool struct. You can see that it's parameterized by the LP coin as 2 different coin types, right? It's just a 2-asset pool, nothing crazy. It only has key. And then you can see the fields. We have a supply of the LP coin. Right, this is what's going to be used to mint and burn the LP. We have the underlying liquidity, which is the balance of coin A and coin B. And then we have the final field, which is the fee field. Okay, now that we've created this, we need a way to actually construct this pool type. So let's add a constructor, just call it new. You provided the treasury cap, you provided this fee field, and then all you do is create the pool, right? This is a very terrible AMM, but it gets the job done. And you can see all we do is unwrap the treasury cap into the supply. We create the underlying liquidity of both balances, and then we just directly pass in this fee field. Right, and you can see in the note here, we don't do any validation on both the treasury cap and the fee field. Right, and then let's say we publish this, and then now let's create a pool from the CLI. I want to make it a Sui AF Sui pool. I've already created the LP type and treasury cap, so I pass those in as environment variables. And then finally, I'm going to pass in a fee field. Right here, I'm passing in 20,000. Okay, nothing about this makes the function fail. So we create the pool, but if you remember, the fee field was represented in basis points, which 20,000 for basis points is equal to 200%. Obviously, we don't want to charge our users 200% for every action. That doesn't really even make sense. I don't know if you could even deposit into this pool. So that's fine. We made a mistake. Let's go ahead and destroy this, and then let's move on and create a new pool. We didn't provide a way to destroy pools, so let's add a function for that, upgrade our contract, and then we can go ahead and destroy it. So let's start with this destroy function. We pass in the pool by value. We unwrap it. You can see the fee field is U64, so it inherently has drop. We can forget about it. The other ones, the other fields, we have to do something with it. You see, we delete the ID. We destroy the 2 balances. And what this is doing, the destroy zero, as the name kind of implies, it checks to see if the balance has a non-zero value. If it does, then it aborts. If it doesn't, then it means it has no value, and you're able to safely destroy this struct. Now we have the LP supply. What should we do with this? Right, the LP supply doesn't have drop, so we need to do something with it. Right, it doesn't have key, so we can't transfer it out. We can't share it. We can't make it immutable. there's not really an intuitive option for what to do with this supply. But since it has store, right, and our goal is to destroy this pool, we have to store it into something else that has key and then do something with the ownership of that new object. So I don't show it here, but in my mind, the most intuitive option to do to kind of solve for this is to create a locally defined struct. I would likely call it like transferable supply. It has key. It takes one supply as its only field as an ID, and then the other field is a supply. So you wrap this supply into this transferable supply object, and then you can do one of three things. You could transfer it to the null address. You could transfer it to a random address if you wanted, but you could also you could share it, or you can make it immutable. I'll do that first option of transferring it to the 0x0 address. And then now we've successfully gotten rid of the supply, and we can finish with this destroy function and move on and destroy it. So that gets the job done, but in my opinion, it's ugly. It doesn't make sense. Why, if I want to destroy this pool, do I need to transfer the supply to another address just to get rid of the pool and reclaim the storage rebate, right? And then there are a few other problems that you're facing with here. Primarily, like, if you're any of those options, but particularly if you're sending to the null address, 0x0 is just going to continue to grow with objects that will never be able to be freed up in Sui's global storage. So that's a pain point, right? And then also, this kind of goes against the idea of the storage rebate. Ideally, you want to destroy this pool, you should destroy everything associated with it and reclaim the storage rebate for all these underlying structs. And because you're either transferring it, sharing it, or making it immutable, you're not able to claim that storage rebate. So a more intuitive option would be what's commented out down there. Just provide a destroy zero function for the LP, the supply itself. So that's what this SIP does. It's kind of crazy that something like this doesn't already exist, and you have to fall back to one of those other solutions. So precisely, this SIP proposes to add two things to the Sui framework. One, to the balance module, we're just adding a destroy zero supply function. Unfortunately, the destroy zero namespace is already taken up by the balance destroy zero, so I just append underscore supply. And you can see it's doing the same thing, what you'd expect. Check that the value is 0. If it is, then unwrap it and you're good. If it's not, then you abort. And then the other thing that's also equally as important is that the use function alias at the top. We're renaming the destroy zero supply to just destroy zero. So you're able to call supply.destroy zero like you would want to, right? Like you can with a balance or a coin. And then the second thing we add with this proposal, same idea but for a treasury cap, right? So now if your pool holds the treasury cap, you can still destroy it. And same thing with the function alias. Okay, this one's very simple. I hope you guys don't have questions here. If you do, reserve it till the end. All right, this next one, SIP 53, gets a little bit more complex, but we're still sticking with move. This one proposes adding a new ability modifier to Sui move. So to date, any of the move dialects, right, they all have 4 different move ability modifiers. You have key, store, copy, and drop. Right, and all dialects of move have these same 4 abilities. Right, so what this SIP is proposing is adding a 5th ability modifier, singleton. Right, and this kind of does what you'd expect it to do. You attach it to a struct, and the bytecode verifier ensures that you can only ever create one instantiation of this struct. Right. So I'm going to first show some examples of today of where I see that this could have already been applied if this was this had been here. And then I'll show some examples from our code on some design patterns that I use to kind of emulate the singleton idea. And then we can get into what are the benefits of this. So here we're looking at the Sui framework. I'm going to show 2 examples from the Sui framework. This is some random object authenticator state. You can see in its description, right, the first 3 words, singleton shared object, right? Second object, I'm sure we've all used it, the clock object. First 3 words, singleton shared object, right? We kind of trust that these objects will be singletons, and we know that through documentation, but there's nothing physically within the Sui protocol that enforces this, right? But we do trust that there will never be 2 clock objects, maybe with disjoint timestamps. And then we keep going. There's a Sui system state, which doesn't have any documentation, but I'm sure if it did, the first 3 words would be singleton shared object. Okay, and then this is moving on to one of our more recent packages. This is going to use a pattern that I'm sure everyone uses, right? I'm sure often when you're writing a package, you have some global, within the package scope, you have a global admin cap. First thing you can see that we do here is create the package admin cap and then keep it, right? So we're transferring it to the publisher or the sender. This admin cap is a singleton object. You can also see the second thing we're doing is creating a singleton config object. We're also sharing it, but the function name doesn't really convey that. And then if we look at the first part of that first function, create package admin cap and keep, you can see in its definition, in its documentation, we're creating a singleton object, right? You should reference that it's going to be a singleton. You can see the first input that I pass in is a witness, a generic type, I call it witness. And then the first thing I do in this function is assert that this witness is a one-time witness. So that assert in tangent with the visibility of this packet or this function, which is public package, these two in tangent assert 2 things, right? That the type that's being passed in must be a one-time witness. So this function itself must be called from an init function. And then also the public package means it must be called from an init function within this package. So this kind of reduces the scope of where this constructor can be called from. And you really just need to, if you're like looking at the contract on an Explorer, you just need to look at any of the init functions within this package. With this package, there's only one. So you can just look at the scope of that init function, see that you're only ever calling this function once, which means that we're creating an admin cap here. It's a singleton object. Right, and through this design pattern, you kind of reduce the scope. You allow, it's a bit more expressive, right, for someone else looking at your code that this will be a singleton object, and it's kind of the best, in my opinion, the best that you can do today to convey that. But again, I mean, this also adds a little bit of redundancy, but I'm fine with that redundancy, right? I'm only ever creating it once, so I'm paying a little bit of extra gas, which I think is a good thing to express the idea that this will be a singleton object. There is an issue with this, though, is this only ever kind of proves that the object will be a singleton at any given point in time, but this doesn't mean tomorrow, right? If this package is mutable, you could always go ahead and create a second constructor or remove some of these constraints and allow like multiple variations of the admin cap to be created. So right, it does prove like at this given point in time that this admin cap will be a singleton, but it doesn't prove that in the future. Okay, let's get into what are the benefits of the singleton ability modifier. So first and foremost, today without it, there's a whole range of like malicious actions you could perform to kind of bypass the lack of singleton. So I'll use the clock as an example. Although like we should all have a high level of trust within the clock object that there's always going to be one, but it's just an easy example, right? It's kind of more so on these third-party packages that aren't created. They're not the Sui framework. Maybe they're created by some unknown developer. Let's say someone does somehow create a second clock object, right? And then they stop updating it, or they're able to update it to a future timestamp, and then they can pass it in on any active contract that accepts the clock, right? Because we're not accepting the specific version, right? The specific ID, right? We're just accepting clock, and we assume that we trust that it's going to be a singleton object, so there's only ever one you can pass in. But if you're ever able to create a second version, then you can just pass that in, right? And kind of remove kind of invalidate that trust that you had. Right, so adding the singleton ability modifier improves the security because it reduces the ability for this type of malicious activity. And while doing so, it also removes, right, this is primarily, like we trust that the clock will only, right, it's singleton, there's never going to be a second clock. But with third-party packages, right, with the config that I had, or the admin cap, right, you have to trust that I won't create a second config or a second admin cap, and I can do what I can to kind of express that at the smart contract level, but you still need to trust that in the future I won't upgrade or remove this trust. So having the singleton ability modifier and actually utilizing it It removes this layer of trust between third-party packages, which is a good thing, right? You want to reduce the level of trust that you're required to have when interacting with another package down to 0, right? And without the singleton, there's always going to be this level of trust that needs to exist. All right, any questions on this? This one's also pretty straightforward. I do want to mention here, there is a second way. I don't mention this in the SIP, but there is a second way you could implement this. I'm sure there's 100 different ways you could implement this. With the implementation here, not only do you add a new keyword, but you need to update the bytecode verifier to then ensure the actual asserts that there's only one instantiation. But there is a second way you can implement this, right? The current implementation suggests doing exactly that, right? Adding the bytecode verifier check, and it mimics the bytecode verifier check of the one-time witness, which is a little bit restrictive, right? With one-time witnesses, you can only ever create them in an init function, but maybe you don't want that, right? That is very restrictive. I think that's a restriction that's fine, that's having, but maybe someone else doesn't. So a way you can get around that is by creating, say, in the Sui framework, a shared, or like a singleton registry object, right? And then every time that you create an object that has a singleton keyword, you would then need to register with this registry that you're creating this, right? And the bytecode verifier would check that when you're constructing, when you're creating a singleton object that you do in fact call the register function on the registry. Right, and then this registered function call would then check, has an object of this type already been registered? If so, then you fail. If not, then you register it. You keep track of that, and then you're able to create the new object. I personally don't like this, going this route, and that's why I didn't even include it in the SIP. But it does kind of completely switch that restriction of you can only create a singleton object on or within the init function. Now you can only create a singleton object outside of the init function and not within the init function, because unfortunately you can't pass the shared or the singleton registry object as input to the init function. So it completely flips that over. And I think that part becomes a bit too restrictive. And then also you're storing this mapping on chain within an object, and I don't think you need to do that. Okay, last time, any questions on this? Okay, now we're going to start moving up the stack. The first two are primarily focused on updating move, but now we're going to get into the wallet standard a little bit, and more so in the user experience, right? These are more user experience focused than developer focused. So what is one-click trading? So this is like a well-received, well-adopted idea within Web3. And very succinct, it allows auto-accepting of transactions. Right, so like if you go to our site and you try to make a swap, right, you'll get this approve transaction modal pop up, and then you have to click approve transaction, and you do a second swap, and you have to click approve transaction, and you keep doing that, right? Every action you're going to do, say you do n actions, for each of those you need to approve the pop up that appears. What one-click trading does, if you're on an app that has one-click trading enabled and you enable it, it kind of removes that, right? So no longer do you have to accept approve a transaction, it just auto-accepts for you behind the scenes. Right, this is a very important feature, right, that kind of lacks on Sui. And it benefits a few domains in particular. Latency-prone domains greatly benefit from this. So if we go back to the spot trading example, say you're a meme coin trader, a meme was just launched, a meme coin was launched, 10 seconds ago, and you want to trade it. Right? In those first few seconds, the price is going to shift dramatically. Any user delay that you take to move your mouse to go say accept a transaction, that's time in which the price is diverging from what you want. Right, so in scenarios like this, right, where the latency matters tremendously on the execution you're going to get, this is a huge unlock. And then also on the other end, right, in domains where you're going to be executing a lot of consecutive transactions, like the poster child example here is gaming, right? When you're playing a game, you don't want the user to have to stop every few seconds, right, and click accept transaction. Right, so these first two domains like greatly benefit from a user wanting to enable one-click trading. And then in my opinion, I really think that this is, right, Sui has really removed a lot of the hurdles, right? They've started very low level and worked their way up and started removing a lot of the hurdles to kind of achieve a Web 2-like experience. And I think this is one of the last, if not the last hurdle that they need to remove to really allow you to replicate a Web 2-like experience onto Sui. Okay, so what is the solution that we propose within this SIP? So very, very standard, what you'd expect. We just want to extend the wallet standard with an API around auto signing of transactions. In tangent to that, I also think we could really abuse certain factors on Sui. We can really abuse, in particular, the object-centric data model of Sui to really allow fine-grained filtering of transactions. Right now, I'll get into some of these. Let me show all of them first. Right, so I mentioned Sui as object-centric. You can really abuse some of the factors there, right? You can allow users to specify an object ID, a series of object IDs that they want to auto-accept, maybe object types. Maybe they know for their session they're only going to interact with USDC, they're only going to interact with Sui, and they know they're not going to interact with any other coin types. Maybe they just want to auto-accept for safety, they only want to auto-accept transactions that touch those two. Right, you could do number of objects, you could do number of transactions, you could do a move call filter, right? So if you know you're only going to interact with, say, Aftermath, and maybe within that you're only going to interact with our IMM, then you could do a subset of move call filters for our packages or our modules within our AMM. Same, again, like the package filter. This first one is going to be the biggest unlock, and that's origin-based, right? So often, you're going to log onto a site, you know you're going to be there for maybe 20 minutes, right? You want to just auto-approve any transaction that comes from that site. But I think having a level of granularity where you support all of this is really huge for the user, right? You want the user to be able to specify, you know what, I'm going to be here on Aftermath for 20 minutes, so I just want to do origin-based. But maybe they don't want to like auto-approve any transaction, maybe just a subset of the domains that we provide. Maybe on one app they fully trust it, so they just want to do origin-based. Maybe on another app it's the first time using it, it hasn't been audited, so they want to be very restrictive on the type of auto-accepting that they want to filter. And then again, if you do accept a transaction that doesn't meet one of these criteria, then all you have to do is click auto-accept. Right, and then the last thing is the expiry. And this is really what's going to allow you to replicate this idea of my session is going to be 20 minutes, my session is going to be 30 minutes. I'll just set an expiry for that.